I'm recording it now. Thank you.
All right, good deal. All right. All right. So it says, you know the payment amount for a loan and you want to know how much was borrowed. Do you compute a present value or a future value? So you know what the payments are, but do you have to do a future value or a present value? So you know the payments. I'll put them in as PMT. They're known. The answer to that would be you're always looking for the loan amount, which is a present value calculation. And it's pretty common to have these types of problems. Every loan that's written has a timeline that looks kind of like this. It's a loan amount that's a payment amount, and then the bank is basically making trades with you. They're going to give you a lump sum up front, the present value, lump sum. You're going to promise to pay them a smaller payment periodically. And banks do this all day long. They just make that trade. Well, how much should this loan value be given the payment amount? And it only has, the only adjustment factor is that interest rate. So it depends upon the rate, right? And so these are always present value calculations. So the next part says you want to receive $5,000 per month in retirement. If you can earn 0.75% per month and you expect to need the income for 25 years, how much do you need to have in your account at retirement? Okay, so very similar question here. This is what you know. You want to receive $5,000 per month in retirement. You think you're going to live 25 years in retirement. So 25 years times 12 months in a year. I'll do that little calculation over here on the side. That's 25 times 12 is 300 months. And that you want $5,000 per month in retirement. And so you're gonna, what you're telling me is that you want 300 payments of $5,000. Tells me also that you're going to get 0.75, and that's actually called 75 basis points. So a basis point is 1/100th of a percent, right? And so 0.75%, and that's per month, is 75 basis points per month, okay? All right, so everything is already set up here in monthly terms. We got the interest rate in months. We have the time period in months. We have a monthly payment here, $5,000. If I were to do this the really long way, I want to work the math out for you just to see how useful Excel is, because you'd never really want to do do it this way. But they want to know how much will you need to save today or at retirement. So at retirement starts at time period 0. And when you retire, then looking down the timeline, you want $5,000 payments coming to you for 300 months, right? To me, that looks exactly like a loan too. It's really no different, right? It's a bank making a loan looks just like you planning for retirement. You have an annuity here all the way out to 300 months. And the question is, how much do you need lump sum given an interest rate of 0.75 per month? So this is a present value calculation. And when you do it the long way, it's the present value today is the sum of all the present values of each one of these payments of $5,000. So this first payment of $5,000, we're going to take the present value of it, take 5,000 as the future value, divided by 1 plus the interest rate is going to be 0.0075, because we're putting it in decimal form. We don't need to divide it by anything because we're dividing normally by M. It's already been divided by M. In other words, you've already been taken, you've already been given it in monthly terms. And so that's why you don't have to do any division. Then we're going to raise it to the number of years, which is N. That first one comes after one single month. So 1 month is 1/12 of a year. So N is 1/12, M is 12. So this actually turns out to be 1, the first period. So the number of periods here is 1. And then we move to the second payment. That's the second payment of $5,000 that comes in 2 months that we want is 5,000 divided by 1 plus, again, 0.0075, now raised to the 2/12 times 12. Again, those 12s cancel and you have the NPER, number of periods for this one payment is 2. And you do this 300 times. I'm going to put ... all the way out to the 300th payment. And that last payment, present value, is going to be 5,000 divided by 1 plus 0.0075 raised to, and it's 25 years times 12, which is 300. That's the number of periods. So that's long and nasty. 300 terms. You would never want to do that by hand, right? When we go into Excel and do this, it's very simple. All we have to do is hit equal, present value, open the parentheses. Excel wants an interest rate that is matching the time period of everything else you input. So interest rate is 0.0075 is a monthly interest rate. That's my R over M. Then it wants the number of periods. Well, that's N times M for the very last payment. So we're telling it we want 25 times 12, which we know is 300. We could have written 300 in there, or we could just type it in. We're telling Excel, give us 300 payments of $5,000 each. So the payment, PMT, is the annuity payment, and it's a monthly annuity payment. So 5,000 is monthly. And then there is no future value here, right? There's no lump sum single value at this last time period to take into account. That's where we would put some sort of like balloon payment if it existed, but we don't have a balloon payment here. The type we're going to leave as 0, and that is because I don't read anything in this problem that tells me that it's anything but an ordinary annuity. Most of these loans are ordinary annuities, right? And all I have to do is hit enter, and we need to have in an account today to retire and receive $5,000 a month for 300 months. We would need $595,808.11. All right, any questions? Okay. Let's see. So finding, now we're going to compute the payment. So this is a different sort of question. We're actually going to be computing a payment where it says, suppose you want to borrow $20,000 for a new car. And let's put a new timeline up. And you want $20,000, $20,000 car today. The present value is $20,000. You want to receive in $20,000 to buy a new car. You can borrow at 8% a year. That would also be called the APR, annual percentage rate. So this is in annual terms, 8%, and that's per year. That is normally how they're quoted. It's rare when you see it quoted in monthly terms like we had on that last problem. It's almost always in an APR form. And this loan is going to be for 4 years. And the question is, what is the monthly payment? So 4 years is 4 times 12, which is 48 months. And the question is, what is this payment? What's your car payment going to be in monthly terms? And again here, if we did the math by hand, which would be really take a long time, the present value, the bank is going to give you $20,000 today. That must be equal to the present value of the payments. So the first payment, which I'm just going to leave in as a variable here, is PMT. I'm going to divide it by 1 plus. It's going to be 8% annually. We do need to divide that number by 12 because we're R over M. We're given it in annual terms, so we're given R, but we're going to be computing this monthly payment in monthly terms. So we've got to divide that by R, or sorry, M, and then this first payment comes after 1 month, which is 1/12 of a year, times M is 12. And so this first one is cancels and you get the first payment. And then we do this 48 times. All the way out to the last payment, which is payment divided by 1 plus 0.08 over 12 raised to, and this is the 4 is the number of years times 12 is the number of times compounded per year. We'd have to take that equation and then we would algebraically solve for payment, which would take a long time. All right, so to do this in Excel, it's super easy. We just hit equal, PMT, open up the parentheses. So I think this might be one of your first times doing a payment question. Works just the same way though. You just have to hit equal, PMT, open up the parentheses, and it's going to give you a little cheat sheet. The interest rate they want in is a periodic interest rate. In our case, it's monthly. So 0.08 divided by 12. Does everybody understand the fact that, you know, last time we did a problem, we didn't divide it by 12, and this time we are? Does everybody understand the reason why we're dividing it by 12? Because we're given an annual interest rate. That is R. We have not already, they've not given us a monthly interest rate. They gave it to us in annual terms. If you want your answer in monthly terms, you must put everything into Excel in monthly terms. So that's a monthly interest rate of 8% divided by 12. The number of periods is going to be 4 years times 12. That's 48 months. And then the present value is 20,000. Close up the parentheses. Our monthly payment for that car is going to be $488.26. You guys want to do an amortization table on that just for fun? Just for fun. Let me get this so everybody can see. I'll set an amortization table up here. Insert a column. Here's going to be my time. This is going to be my payment. Then interest, principal, and the balance. Okay, everything's fit in there. I'm going to start this off with time period 0, and we're going to go out to time period 48. Whoops. Okay, so just so I don't have to be subtracting a lot of negative numbers, I'm going to go up to this payment. I'm going to put a negative sign in front of it. So my payment's positive. Then I don't have to think about the math too much. My balance is going to start off at 20,000. And let me make this just a tad smaller for you so you can see the whole thing at once. Okay, so then I'm going to go down to my next row, which is period 1, which is month 1. And I'm going to hit equal, and I need to compute how much interest I owe. And the interest I owe is going to be 8%. And actually, why don't I cell reference this? I'm going to put my interest rate up here. So the rate's going to be 8%, 0.08. And I'm going to cell reference everything I can. So I'm going to hit 8%. I'm going to lock on it by hitting F4 on a normal computer. On a Mac, it's Command T. I think someone else told me it might be Shift F4 on a Mac. But if you need help, just Google it and find out what you do to put those dollar signs in there quick. And I'm locking on to D1 for that interest rate. And I'm locking those dollar signs. The first one in front of the D locks on to the column D, and then the dollar sign in front of the 1 locks on to the first row. And so that identifies a single cell that it's locking to, and it won't change from that. So it's going to refer to that interest rate over and over and over again when I copy my formulas. So I'm going to multiply it. I'm going to cell reference this balance. And I'm not going to lock onto that balance because the balance is going to change. So every time I make a payment, my balance is going to go down by the amount of principal that I pay, right? And if I just stop there, that interest amount, which I'll click on it, it's $1,600. That's for the whole year if the balance were 20 grand. So what I need to do is I need to divide that number by 12, and that will give me my monthly interest that I owe after that very first month. Right? All right, then, so I owe $133.33 in interest after that first month. The principal then is going to be what's left over from my payment. So my payment's $488. This time what I'm going to do is I'm going to go Command T. I'm going to lock on to that payment. Right? I think the last class what I did was I copied the payment all the way down the column, and then I didn't have to lock on to a single cell. But today I'm being lazy and I don't want to copy the whole thing all the way down. So I'm just going to refer to that one payment over and over again. And then I'm going to subtract from it the interest that I owe. And that amount, that is going to go to principal. Right? That's the amount of principal that's going to be paid down, which is $354.93. All right, so then the balance is going to be my previous balance, and I don't want to lock onto it because it's going to change every single month. And I'm going to subtract from that my principal. And so my balance is going to go down by $354.93. I have to copy all 3 of those equations at one single time. I cannot do this separately. They're all intertwined. So I'm going to copy that all the way down to period 48. And I will have gotten this right if that balance at time period 48 is 0. That's how I know I'm right. Right? This is a fully amortized loan. And I want you to look at that amortization. Every single payment, the payment itself stays the same, but the interest, notice, every single payment you make, you pay a little less interest. So the interest is falling every single month. The principal is rising every single month. So that which you're not paying in interest, it gets shifted over to principal, and it reduces your balance quicker, right? All right, so if you wanted a question here, how much would a $50, if you decided I'm going to pay $50 extra every single month, right? You can do this in several ways. You can add that to the payment and just say add $50 if you're committing to it. And every one of your cells will change when you cell reference it properly. And you can come down here to the bottom and you can see that that extra $50 every single month is going to take off, it looks like 1, 2, 3, 4, 5, 6 payments for you. So it's going to basically reduce your car loan's duration by six years, right? Or here's another way you can do it. You'll get the same answer, but instead you can add it to the principal. You can just say add $50 to that very first line, but then you have to come in here and copy this down again. Oh, looks like we're stuck. Make sure I did that right. Hold on. I'm having trouble with my mouse here. I think my batteries might be almost out. But you can hear those are the same numbers. And so you're basically, again, paying off your car loan by six months early. Another way you could have done that instead of adding it to the principal, so I'm going to subtract that off. You could have subtracted it from your balance. It would work the same way. So I could subtract 50 bucks from the balance. And you can see here when I copied it down, I get the same exact numbers. So 3 different ways to form a amortization table. Now, the one thing I really like about being able to do this yourself, rather than actually depending upon your banker to give you your amortization table, which they're legally bound to do, is that you can actually do these what-if scenarios. You can go in and surgically say, well, I can't afford $50 a month every month, like we had it set up there, but I could afford $50. Let me make sure I have it set up. Copy it down again. But you can go in and surgically say, well, every so often, maybe I get a bonus every Christmas, and maybe in 12 months, I'm going to get a bonus, and I could go into that 12th month, excuse me, and surgically add, maybe I get a big bonus and it's $1,000. I can add $1,000 one-time payment 12 months from now and see what that does to my actual payoff. Looks like it takes off 3 months. Right? That makes sense to everybody? Everybody good? Okay. All right. So we've taken this one question about finding a payment, and we've done everything we could to it. So I could ask you, like, if to do an amortization table, which you have to compute the payment for. And that amortization table tells you lots of stuff. You know, it tells you how much every payment is made up of interest, and it's made up of principal, and it tells you exactly how much. So if I ask you on time period 24, 2 years from now, that payment has $74.73 worth of interest in it, $413.53 of principal. And let's say after 17 months, how much do you owe? Well, I owe $13,633.49. Now, I cell referenced my interest rate up here. And I did that for a reason, because I can now change that interest rate. And that interest rate, oops, I think I need to cell reference it in that payment or I won't get this right. So I need to cell reference it there. But otherwise, I think I can just cell reference that payment. And let's say I change that interest rate, like today, interest rates are very low. Interest rates are maybe for a car loan, maybe 2%. All right, and when I put in 2%, you can see that that changed my payment. Right, went from 488 down to 433.90, and you can see you pay off over the same period, 48 months. But if you look at how much interest that you owe over the course of the entire 48 months, you can see that it's $827 worth of interest, $20,000 worth of principal, as opposed to when that interest rate was at 8%. At 8%, look at the interest that we're paying, $3,436. That's a big difference in the amount of interest that you end up owing over the course of 48 months, right? Any questions? Everybody's good? Thumbs up? Okay. Let's try another one. Okay, so this is a great one. I wish we were in class for this. Because I normally what I do is I take somebody's credit card information. I want to make sure everybody understands how credit cards work. So here we have a problem. You ran a little short on your spring break vacation, which we haven't had spring break, so this can't really be true yet. But you put $1,000 on your credit card. So does everybody, can some of you turn your mics on? Anybody that has a credit card, turn your mic on and tell me, let's have a conversation about how your credit card actually works. Anybody got a credit card?
What do you need to know?
Oh yeah. Okay, so if you put $1,000 on your credit card and you pay it off at the end of the month, do you pay any interest?
My interest is 7.5%.
So your interest rate, 7.5%, is that annual?
Yes.
Wow, that's a really good interest rate for a credit card. I think mine runs closer to 17 or 18%. Usury laws in Louisiana put it upwards of 30%. In other words, a usury law is a cap on the interest rate. So some people are actually paying like close to 30% interest on a credit card. All right, so what would happen? So we've already determined if you put $1,000 on the credit card, you swipe it at, say, Walmart now. You put $1,000 on the credit card. It doesn't close out till the 13th of April. You pay no interest on that $1,000 purchase between now and when it closes out in April, if you pay the loan off, because you're taking out a loan here. You're taking out a $1,000 loan when you swipe your credit card. And it's 0% interest as long as you pay it off in full at the end of the month. So when your credit card's due. All right, what happens if you pay off $999, leave $1 on April 13th? What happens then?
Wouldn't only the $1 be have interest added upon it?
So not only is that $1 going to be charged interest starting at that point, in your case 7.5%, but every single dollar you charge from there on, you don't get that 1 month kind of period where you get zero interest anymore. You will be charged 7.5% interest on every single charge you make from the moment you make it for that entire month. that make sense to everyone? How that works? A lot of people don't understand how a credit card works. It is a loan. They are typically very high interest rate loans. And why do they charge such high interest rates on a credit card versus is very low interest rates on mortgages? Mortgage rates are, you know, if you do a 15-year loan right now, you can get it maybe 2.75% versus my credit card, and I have very good credit and never been late, always paid it off in full. My credit card, I think, is at 16% annually. That's a very big difference. Why the big difference?
The balance amount, the house has a much higher balance amount.
Say again, Terry.
Because the amount that you're borrowing is much greater with a house than it would be with a credit card.
Well, wouldn't you say that's riskier then?
I would say it's riskier, but I mean, 2% of 300,000 is a lot more money than 2% of 1,000. So.
Yeah, true. But let's keep the conversation on the actual difference in rates. So actually, my credit card, I think, has a rate. It's 16%, but I actually have a really high limit. I could actually purchase a car with my credit card. And so the credit card limits will vary. You guys at your age probably are around $1,000 to $2,000, you know, would be a pretty decent credit line. But it has nothing to do with the amount that you're borrowing. It has everything to do with the riskiness of the loan, right? So the idea is that what do you guys spend on your credit cards? What kind of purchases do you put on them?
Just gas.
Gas?
Like airline tickets.
Airline tickets, maybe food. Yeah. Okay. So these are kinds of things that are monthly expenses, you know, expenses for, you know, to get to work, expenses to, you know, take your vacation. These are kind of monthly expenses. The reason why those interest rates are so high on credit cards is because if you don't pay it in full, you're sending a signal to the bank that you are not making ends meet and you're having to borrow and you're having to do it every month. Does that make sense to everybody? If you don't pay off that credit card, it's a really strong signal to the bank that you have the credit card with that you're not making your income and your expenses meet up. In fact, you're having to borrow to close the gap. And so the bank takes that as very risky behavior. Right? So, and for very risky behavior, they're going to take on more risk. They're going to require more return. And with that said, that's why you have really high interest rates on credit cards, right? So here's the case where you ran a little bit short on your spring break and you had to put some money on a credit card. It says you can afford only the minimum payment, which is $20 per month. So every credit card has a minimum payment. What does that minimum payment mean? Is anybody paying the minimum payment on their credit cards right now? Because it's a tough thing when you get into that bind. The way that these credit cards are set up is the minimum payment at best covers the interest that you owe per month, right? It is rare when you find a credit card that's been set up to where it pays much more than the interest. In other words, where your balance would actually start falling. And in fact, some credit cards are set up to where you pay that minimum payment is less than the interest that you owe. And that means that your balance would actually grow over time without making even one single more charge to it. So let's talk about this. So the interest rate on your credit card, this one is at 1.5% per month. And credit cards are one place that I do notice that they sometimes have it set up monthly and it's in the fine print and they'll have it monthly because the rate annually would be 1.5 times 12. That's an 18% interest rate annually. That's the APR is 18%. So last semester I had a gal in my class and she actually got her credit card out And she was going through all of the rules of her credit card, and I asked her, what's the interest rate you're being charged? And she said it's 0.00, it's 0.05. And I said, what does that mean, 5%? And she said, yeah, it's 5%. I said, wow, that's amazing, because that's annual. And then she got to reading it really carefully. It was monthly. That's really high, right? Monthly. And so she was learning about the fine print and how they were actually stating it on her interest on her statement. All right, so the question is here, how long will you need to pay off this $1,000? So this big spring break trip you took, I'm going to write a timeline down. And bottom line is your loan value is going to be $1,000. The moment you swipe that credit card, you're taking out a loan immediately for $1,000. And you can make a payment of $20 a month. This is your minimum payment. Now the credit card has that minimum payment on there. If you keep paying that minimum payment, it keeps you out of what I call the default pile. Once you get into the default pile, the credit card is likely to go after you, close down your credit card, and possibly go after assets, potentially force you into bankruptcy, that kind of thing. So the minimum payment keeps you out of default, keeps you out of getting your credit card, retrieved by the bank, but it doesn't pay off the loan that you borrowed very quickly. All right, so this question is all about how long is it going to take us at 1.5% interest per month, which we already concluded was 18% APR, which is pretty high. All right, so these numbers I'm putting on our timeline are months, right? So what kind of question this is obviously a number of periods question. How many monthly periods will it take us to pay off this spring break trip? All right, so if I were to do the ugly math by hand, this is what it would look like. The present value today, $1,000, is equal to the present value of this string of $20 payments. That's $20 after the first month. That's present value is 20 divided by 1 plus 0.015. That is a monthly interest rate. So that already is R over M. Already. So we don't have to divide it by 12. We're going to raise it to the 1/12, which is first $20 payment comes after 1 month. So 1 month is 1/12 of a year. So N is 1/12. And M is monthly compounding. And so that is, M is 12. And so these guys cancel. And this is your first period. This goes on. And we're actually trying to solve for number of periods. So we're solving for N times M. That is what this equation is set up to do. Now that would be hard. It might even be impossible to do it by hand, really. All right. So in Excel though, it's pretty easy. All we do is we hit equal. We're going to have to be really careful with our signs. So as far as inflows and outflows, we need to think about it. This is a number of periods problem in PER. We're going to open up the parentheses. The interest rate is 0.015. That is a monthly interest rate. The payment is, I'm going to put in minus 20. That is a monthly outflow that we have promised. The present value is an inflow to us of $1,000. There is no future value, and we're going to assume this is an ordinary annuity, so the type is 0. Close up the parentheses. 93 months. So we get this answer, 93, and we have to determine, well, what is this? Is this months? Is this years? everything that we put in here. It was a monthly interest rate, a monthly payment. And so Excel is going to give us the number of months that it's going to take to pay off. So that's 93 months. Well, 93 months turns out, if we divide that by 12, turns out to be almost 8 years. So that that spring break that you just charged $1,000 for could take you, if you just did the monthly payment, it will take you almost 8 years, 7.76 years exactly to pay off. Now, would you guys like to do an amortization table on that so you can see item line by line? I think this is really interesting, actually. And I'm going to set this up where I've got time here. I don't really know what the time is. We computed it, and we've got, I'll put in payment, interest, principal, and balance. And our balance starts out here at $1,000. And I'm going to put in some time, but I don't know what the time is. I do because we've already calculated it, but I'm just going to go out here. That's good enough. Okay, so when I do an amortization table here, how much interest do I owe after that first month? It's going to be 1.5% of my balance. All right, so my balance is $1,000. $15 is how much I owe just in interest. So if I'm making a payment of $20 a month, that leaves me that this first month, it leaves me only paying off $5 in principal, right? It's not even probably, you know, every month you're basically paying off one beer, right? One beer that you might have had on spring break. So that first month, if I'm just making the minimum payment, it's going to be, my balance is going to decline, but very, very slightly. I'll have a balance of $995. All right. So if I just keep doing that, and I'm going to put in the principal here, I'm going to freeze to that payment, copy this thing over, and you can see when I copy all the way down, if this is the choice I make and just make the minimum payment the credit card forces me to make, you can see where the balance goes from positive $2.20 here in time period 93 to a negative amount where you got the thing paid off in before. So it happens between 93 months and 94 months. And so a lot of credit cards, though, they're set up to actually, if you pay the minimum payment, oops, that's the wrong amortization table. Here we go. If you make the minimum payment, you can see at best you're making a small contribution to the principal, but a lot of them are set up to where they're actually negative amortizations, which means, like, let's say that they set the payment at $12, right? If the minimum payment is $12, then you owe $15 of interest after that first month. That means you're borrowing another $3, and your balance is actually going to grow. And you can see here, if that's the case, it will never, your balance is actually, oops, didn't copy it all the way down. If you do this, your balance will never go down. It's only going to rise. And so if you make the monthly payment and your credit card is one that's set up to be a negative amortization, and you go out here to 100 some, whoops, yeah, 100 and some months, 104 months, you're going to have a $1,740. All right. Any questions? Any questions about the amortization table? All good? Okay. All right. 10 more minutes. My husband's trying to kick me out.
In 10 minutes.
He's got 10 minutes. He's got a class in 10 minutes. Let's do one more problem. So I'll go let him get ready a little bit. Now that LSU's off spring break, I'm going to have to fight for the Love Shack. Okay, so let's do another one. Suppose you borrow $2,000 at 5% interest and you're going to make annual payments of $734.42. We can do this one real quick in Excel. I'll put it up in on a timeline. And timeline here, we're going to borrow $2,000, time period 0. We're going to make payments of $734.42. And it's going to be at a 5% interest rate. That is annually per year. And the question is, how long do you have to make these payments for in order to pay off that loan? And so this is a number of periods problem, and that is NPER, open parentheses, interest rate is 5%. Now, the question asks for you to give the answer in annual payment form. So in other words, everything's going to be put in annual terms. So the number of periods is going to be in annual terms. So the interest rate's 5% annually. The payment is $734.42 per year. And then the present value is $2,000. We're going to assume there's no balloon payment for the future value, and that this is an ordinary annuity, which would have a type 0. And it would take us, whoops. We've got to make sure that our signs are right. There's no way that you can have a negative number of years. And so the signs aren't correct here. And did you notice how it actually lets you get away with that error? And so it doesn't give you an NUM error. Instead, it will give you a negative number of periods, which makes no sense. So what we did here is we have a loan value of $2,000. We're making payments out of $734.42. And then we hit enter and it's right at 3 years. All right. So be careful with that. You saw me just make that mistake. I got the signs wrong. This is the one case where you can actually get the signs wrong and it will give you an answer, which is a bad thing. It doesn't just automatically give you an error, but it gave you an answer, but it didn't make any sense. It was a negative number of years. All right. Is that good? We'll close it up since I'm getting pushed out here. Any questions? Okay. I will get Alvin to send me the link that's on YouTube, post it, and I'll also give you guys the other classes link as well. All right. Thanks, Alvin, for doing this. See you guys later.
Later. Have a good one. Yeah.
Later.
I'll send you the link once it finishes. Or once I post it, I mean.
Doing it, sometimes it takes a long time and sometimes it's real quick. I don't know. My 447 class earlier, it didn't even start to convert. I gave it 15 minutes. So sometimes it takes a long, long time and other times it's really quick. I have no idea why. So it's best that probably you handle that since I will lose it if I start a new session. Like as soon as my husband starts his session, he might lose it for me. So it's a good thing that you're doing this. Back up. Thanks.
Yep, no problem.
See you guys later.
Yep, have a good one.